Hello everybody, welcome to our post-apocalyptic plot hop. I'm glad to see you're all well and healthy. I know you're sick of COVID, so I'm happy to have you out here. We do have lots of space, so try to maintain all the rules. I know you've heard it over and over and over again, but we're also live streaming our plot hop today. So little bit nervous. You can see our makeshift production unit over here. This was all prepared. We weren't sure at the beginning of the season whether we'd be able to have anything at all. We found out that trying to do both a live and a streaming at the same time was probably a mistake. So if you could bear with us, a little bit of patience, because sometimes we actually have speakers that weren't able to make it. They are going to be giving their presentations from off-site. So we've actually got a TV mounted on our Kubota there. We have to drive extra slow not to wreck it, and all of Morton's fancy gear there. So hopefully we'll still have a good opportunity to learn. I think as long as we get together and we share our ideas, it'll be a great day. So thanks again for coming, and remember, just a little bit of patience as we work out the bugs today. All of these presentations will be available online as well after the fact. So if there's things that get missed, you have an opportunity to go back and see it again. If I didn't introduce myself, I'm Ken Coles, Executive Director of Farming Smarter. Just wanted to give kudos to all of the people that worked really hard. We've got a whole bunch of summer students, actually 2 college interns as well on the manning the camera, so good opportunity for us to partner with the college and the digital media group. Got Morton with KT Communications, Jamie's our assistant manager. Anyways, and Carlo at the back. If you need anything, please feel free to ask us. There are a few porta potties at different areas too. Just down this way, there's one. If you guys need a lift or anything like that, or need to go back for a call, just let us know and we'll try to do that. We've provided you with our fancy Farming Smarter bandanas, so if you do have to get in within your 2 meters, then we just ask that you're wearing your masks. Same thing with the trailers. I think we have just about enough space to give you guys your space on the trips, but if we get crowded, then you've got the mask to go up on. So first of all, I'd like to introduce Mark Oostlander. Thanks so much, Mark, for coming. We've got a nice demo here that we're going to talk. Mark's from BASF, known him for a lot of years. Him and I both like hunting, so then we're automatic friends. So without further ado, I'm going to pass it off to Mark.
Okay, thanks, Ken. Good morning, everyone. So as Ken said, my name is Mark Oostlander. I'm a Senior Research Manager for BASF Canada in the herbicide group. So I spend my entire life, from the time I get up to the time I go to bed, thinking about herbicides. And so we'll have a nice demonstration today to talk about some herbicides and maybe some of the negative effects that we often see out in growers' fields. We're kind of going to go through a few things. We're going to talk about Symptom Ology, what to look for in a field. If you suspect you may have had a tank contamination, what to look for, the individual plant symptomology from a couple different groups. We'll talk about patterns in a field. When you diagnose a field, it's very diagnostic. Where you see those patterns can often tell you what happened. And then we'll talk about tank cleanout and how important that is, and what are some of the best practices we can be doing to clean out a tank. Just to get to know everyone here a little bit, how many of you are producers or farmers? We've got some farmers. I'm sure you've cleaned out many tanks in your life. How many of you are agronomists who go out to farmers' fields? We get agronomists, and then how many people work in industry doing a lot of different things. So we have a little bit for everyone here. Tank contamination is not something we love to deal with. As a farmer, we hate to see it. That's our crop. As an agronomist, I find it fascinating, the detective work it takes to diagnose, but I don't love those calls myself. We don't like to see our customers, have injury in their fields. But it does happen, but 100% preventable with some due diligence and time and effort. I'd say it's not common to have tank contamination. We don't get hundreds of calls a year, but in a previous job, I was a tech rep for BASF across Alberta, and I was the person that had to go diagnose all the calls we would get. And you'll certainly run into a number of calls, 6, 10 calls a year where you'd ask to come diagnose a problem in a field, and then you have to go figure out what happened. The biggest issues on contamination is when we're switching crops. So we're going from cereals to canola or cereals to peas. But I see more and more when we go from pre-seed to our first post-emergence in-crop application. And the demo we're going to look at today is focused on some of the pre-seed products. actually pre-seed chemical groups. I'm not going to talk about products because it's not really a product issue. It's just, you know, cleaning out the chemical groups. And the reason we see that is we're using a lot of pre-seed products now, different than glyphosate. You know, 10 years ago it was Roundup, relatively easy to clean out with some water. Now we're adding 2, 3, 4 products to a tank, and we're spraying, you know, several thousands of acres over possibly 2-week period. So product is sitting in the tank for long periods of time. You know, we might get rain or snow and we shut everything down and it sits there for a week and then we go back out and spray. You know, again, we're doing, you know, Roundup, we're adding a top-up product, we're adding adjuvants. All those, you know, cause compatibility issues where we get foaming and sediments and things build up over time. Then what do we do? Our crop comes up and we go spray our canola, you know, after our clean out, and that's usually where we run into our issues. And I see lots of issues on field peas and canola because they're both very sensitive crops to a lot of different herbicides. So it's absolutely critical, you know, as we go from pre-seed to post-emergent in-crop, we're very diligent about cleaning out our sprayer. If we're switching from one crop to another, we want to be very diligent as well. You know, from one pre-seed product to another, not a huge concern. You know, we should be flushing with water, but you know, it's not the same effect as going into a crop with a herbicide. Now the reason for that is herbicides are very active. They work at very low concentrations. And we have a couple demos here. This demo here we're going to start with is group 2 chemistry. And again, I'm not going to talk about products because it doesn't matter. There's lots of group 2s we use pre-seed. Highly effective, very low use rates, very active. And we use them to manage, you know, largely Roundup rated canola plus a number of other weeds. And this is an example of volunteer canola sprayed at the target rate, you know, the recommended labeled rate, and the product is doing its job. We know it's a group 2. We see that yellowing, purpling. That's classic symptomology of group 2 chemistry. Basically, it stops the growth within 24, 48 hours, and then that plant starts to turn yellow, purples, and eventually dies. And the product is doing exactly what it's intended to do, manage the volunteer canola in your field. So this is a 1x labeled rate of a group 2 herbicide. The problem is they are very active at even minute quantities. So this one here is representing a tank contamination at 1/100th of a rate. So untreated check is here. That's what the canola should look like. It's coming along quite nicely. This is the product doing its job, controlling the volunteer canola. But a tank contamination at 1/100th of the rate, so that would represent 1 liter of a spray solution in a 1,000-liter tank. That's a pretty high contamination. But we're starting to see lots of cases of this purpling in the growing point. That crop really hasn't grown any since it was sprayed a week ago. And I suspect this is going to get worse and worse over time. Now, that's a pretty high contamination rate, probably higher than we would ever see in a tank. This one here is 1/1000th of a rate. So 1 liter of spray solution mixed in a 1,000-liter tank. And we're starting to see the symptomology too. You know, again, it's a very minute quantity. It's not going to have the same effect as we saw over here at the X-ray, but we are seeing some yellowing, some stunting. It's only been a week. The group 2s do work slow. I suspect in another week we're going to see some plants that are stunted in here. This is probably, you know, enough of effect to cause yield loss or season-long injury in some of your canola crop. 1/1000th of a rate. And then we went even further to 1/10,000th, and I'm not seeing too much here. That's a pretty diluted rate, but it's not unheard of in some of the research to see effects, you know, at those low concentrations. With dicamba on non-dicamba soybeans, they've reported visible injury at 1/100,000th of a target rate. Like it's a whiff of chemistry can cause an effect, you know. And canola is not as sensitive as soybeans soybeans are to dicamba, but certainly, actually, I see some yellowing in here. So 1/10,000th of a rate, we have a growth effect. Now that does not take much. You know, you miss one little spot in your tank, we can be at that 1/10,000th of a rate. So very, you know, they work at very low concentrations. Now there's a big difference between controlling your volunteer canola on purpose here and causing some injury. You know, this would not be acceptable if this were a weed. Obviously it'd be a complaint and a miss, but again, probably going to cause a yield reduction or growth effect throughout the season at these very low rates. So those were group 2s. Again, the reason I put them in here is because we use a lot of them, and they're very active at low concentrations on sensitive crops like canola, and I see a lot on field peas as well. the sulfonylureas on field peas. Doesn't kill them, but it makes them pretty ugly for quite a while. So watch out for the group 2s. As we go from pre-seed to in-crop, let's make sure we have proper cleaning methodologies. We're going to come down just a little bit here.
Mark, do you expect any major differences amongst the different types of group 2s, or are you kind of pretty much the same?
Well, there are differences, but hard to say. You know, sulfonylureas behave the same, more or less, and there's lots. You know, there's Express, Refine, Metsulfuron, Ally. You know, lots of different ones. They all have some of different properties. You know, but if you look at the labeled rates, they're all very active at very low rates. And chemically, you know, in terms of how we clean them, they really behave the same, which we'll talk about here in a few minutes. You know, certain chemical families have, you know, I wouldn't say cause more issues, but are more prone to tie up in the sprayer than others. And we know that, and as long as we know that, we can deal with it. So understanding the chemistry you're using, reading the labels is a big part of what we have to do when we do our cleanout. And just a comment on questions, thanks for the question. Anytime, throw up your hand. You can make this very interactive. I can only talk for so long, but I would love questions at any point in time throughout talk here.
Will these be taken through to yield?
Well, good question, Ken. We had set these up more as just a visual demo. It's Ken's trials.
Yeah, I'm not too keen on ever taking 1-rep demos to yield. It just doesn't have any meaning without the
Yeah.
There's probably information on quantifying the effect of different concentrations.
Yeah, there is lots of literature, you know, you can find about, on the effect of contaminations on yield. So, you know, it's again more set up for a visual, and we're starting to see it. Probably one more week, it's going to look really nice. So maybe we can grab some photos here in a week yet before we terminate it. But thanks for the question. We're going to jump right down to here. It's really the same demo, but a completely different chemical group. This is group 14. So the Ppo inhibitors, they're becoming very common. We see more and more of them, you know, in our pre-seed products. BASF does manufacture one. This is our product, HeatLQ. I don't see too many issues with it, but I have been called to fields where there have been contaminations, as a result of improper cleanout. So this is the group 14, you know, controlling the volunteer canola, versus the group 2s. These are highly contact. So we tend to get this complete plant death, you know, like that necrosis very quickly, rather than the stunting and reduced growth. So this is group 4 Symptom Ology. This is the 1x rate, the recommended rate, you know, doing what it's supposed to do. This is 1/100th of a rate. And this is where it really gets hard, because as we get to these minute quantities of product, we don't get that same symptomology. Here, I'd say we're starting to see some visual stunting. Typically, if you look really, really close, we should be seeing some spotting on a leaf. I'm not seeing too much, but because it's contact, you can almost count the number of droplets that were applied. There's possibly some here, but we see spotting on the leaf. This isn't quite as severe in terms of a tank contamination because of the contact nature. You tend to burn off some leaves if the rate's not too high, and they'll come back quite nicely, but still set your crop back and it'll be noticeable in the field. So this was the 1x, this is 1/100th, and then we did the same thing, 1/1000th and 1/10,000th. So, you know, these aren't quite as active, these group 14s at those minute quantities, although certainly you can see some effects in the field. All right, so that's some symptomology to look for. It's not always easy when you go out there, because when you get these real low concentrations, they don't always look like they do at the full 1x rate. But one of the symptoms we see is patterns in the field. You know, and how we can identify it's a sprayer issue contamination is looking at the patterns in the field. Now, I tried to demonstrate this with a 2-meter hand boom. And it's one of those things, when you don't want it to happen, it happens, and when you try to make it happen, it doesn't work very well. But there's different patterns you might see in a field that will identify where the contamination is coming from. This would represent, a tank contamination. If your whole field looks relatively injured equally, it probably came out of the tank or one of your primary lines that feeds all your booms. So it's an equal concentration across your entire tank load. That's the worst kind of contamination you can have, because it's going to affect that entire tank load, equally, more or less. But it certainly does happen if we have improper tank clean out, or we miss our main filter or one of our main lines, or down in the sump, we'll see damage across a whole field. It's not always limited to the next tank. I've seen these go on for several tanks, and every field or every tank load that the grower sprayed, we saw a little bit lower and lower concentration, meaning that product's coming out as we spray, and we're reducing that concentration. So I have seen these go on, over several quarters of land if you're not careful about it. The other one we see, and I tried to show it, didn't quite work out, is the classic V. If you ever go to a field, especially where you start off, you might get this big V in the field. So you got dead plants, and then the tapers off to live plants. That's an indication of a boom contamination. And what happens is that product is going through your boom, and your nozzles are clearing as it goes down the line. So very classic. When you see that in the field, it came out of your boom somewhere. And so that's where we want to focus our efforts. What did it hang up in the lines in the boom? Is there a filter going into that boom that we missed? What is the reason? But typically a boom contamination would give you that V pattern in the field.
I actually had the opposite this year, Mark. The V was the part that wasn't hurting. We sprayed seed alfalfa, and it was getting the chemical to the booms.
Okay.
It had this perfect, nice green inverted V.
Yeah, so it's a classic. When you see, typically, happens more often at the startup, when you first charge your booms and you take off, and then it clears its way, and then usually you're okay. Those typically aren't too devastating, because it's limited to maybe a few hundred feet, possibly a few hundred meters. But that can go on for, every time you turn your boom on, you could pull some more out. That could keep happening. Question here?
So these things happen, they can happen. What typically do you see for each of these scenarios? Like the skip step. I mean, I assume there's some producers who don't do any of the steps and
Yeah.
end up with this, but those who do take those steps and still end up with an issue, where do you typically find that they may have missed the proper step or a mistake was made?
Okay. Good question. So the question was, where do I typically see, the mistake happening? What step in the cleaning procedure? I'm going to come back to that one, okay? So if I don't answer it clearly, please ask me again, but I'm going to talk about cleaners and the steps, and certainly cover that one off. One more classic pattern I see in the field is streaking. You might see a strip that goes for a few hundred meters. Might be limited to a section this big, or a section, a couple nozzles wide. Typically, I see that build up on your screens. We didn't clean our screens. We're using maybe a dry product, which does catch onto your screens, and as we spray, it's coming off onto our next crop. So if you see lines in a field, typically it's a screen issue or a nozzle issue, or coming from a very specific area. And then you can identify where on your sprayer that is, and go and fix it. So, as you're spraying and scouting your fields, pay attention to that, because that really tells us where we should focus. There's a lot of parts on a sprayer. I'm going to come back to your question. I'm not an expert on every sprayer out there by any means, so we have to get to know our equipment. And I'd say everyone's going to be a little bit different. They have different configurations, screens in different places, different kinds of tanks. So really get to know your equipment, but that can tell you a lot about where to focus your efforts. How am I doing for time as well, Ken? You can be my timekeepers, so make sure we get everything in here.
You've used 20 minutes so far.
Okay, good. So those are the things we're looking for. And I'm going to tell a few stories. It's not always as simple as sprayer contamination. I've gone out there and seen it where the grower sprayed several tanks of a product, and then it was like the fourth tank, he had an issue. So, that's where it gets to be the head scratcher. So what happened there? And there's a few different scenarios. Same product, same crop. The difference is when he sprayed. These products don't always come out in the first tank. As an example, on field peas, and the grower sprayed, several tank loads of a product. And then he came back a day or two later and sprayed again, and that field had the issue. And what we figured out was that tank sat for a day or two. And that's where we see a lot of issues, is as things sit, you know, the products we use, the herbicides have the adjuvants, they got solvents in them, they're pulling things out with time. And when he just mixed and went, it was fine. The minute it sat, things started coming out in that tank overnight, and then went and sprayed and had an issue. I've seen it before where, again, the grower sprays numerous fields, no issue, changes products, and then has an issue. But again, different products with different properties, different solvents, different adjuvants. Some adjuvants are really good tank cleaners, and they can pull things out that are bound fairly tightly to your tank wall or your booms, and they can pull that out. So it's not always obvious. Like, some of these are really tough to get through, but you can usually work your way through and get to your answer. So that really brings us to how do we clean our spray tanks. It's our favorite job. We all love cleaning sprayers, right? Nothing we'd rather do with our time. But it's one of those chores that we just have to do, and we have to be very, very diligent about it. So a few recommendations, fairly common. You know, I hear Tom Wolfe talk about these all the time. Lots of people talk about these procedures. I have a few extra I'm going to throw in that I recommend. But one is, don't leave product in the tank too long, especially those pre-seed products. You know, we like to load up, spray a few fields, go seed for a few days, come back to them. It's good to spray out your tank in a field, and then when you go park it for the night, throw some water in it and just let it sit. That prevents those sediments from drying and binding to your lines. A little bit of water. The next day, you know, you can top it off with the water, add your chemical, and keep going. But it's really good just not to let them sit for too long, you know, in your yard, if you can avoid it, because things do build up over time. So that would be one thing we can do. You know, watch out for the foaming. I know with all these tank mixes we do, we tend to get some foaming and some incompatibilities. You know, it's a reality. We tank mix for a reason, to control the weeds we got to control, but we see more and more compatibility issues. You know, and so we get a little more sedimentation, foaming. That foam can carry active ingredient. It coats the size of your tanks. So, you know, preventing the foaming, sedimentation can help. When we go to clean our sprayer, we're looking at a 3-step process. And we have a couple of goals. One is dilution. If we can dilute that product far enough, it will be ineffective. We kind of see it here. But we can't count on dilution alone, because as I showed you, even at minute quantities, we can cause injury to sensitive plants. But we are trying to dilute the product to a rate that won't cause an injury. Removal, we want it out of the tank. If there's sediments built up, we want it out. If it's not in the tank, it can't cause an issue. We're also, with numerous chemicals, trying to deactivate. With group 2 chemistries like the sulfonylureas, as I showed there, they're very soluble at high pH. If we can get that pH to the right level, we can, you know, solubilize them and remove them, but we can also deactivate them. So there are deactivators that you can use for certain chemistries, which I'm gonna talk about. So step 1, you know, removal, get everything out of the tank. Start with that rinse, that dilution rinse. You know, flush everything out so you have no water left. Step 2 is our cleaner, and I think this is a critical step, and this is where I see things go wrong, to answer your question, and it's happened to me. We put cleaners in the tank, you know, and I'm going to talk about a few. Sometimes we're using the wrong cleaner for the wrong job. We think because it says tank cleaner on it, it's good for everything. It's not, and I'll talk about that here in a minute. But we throw it in a tank, slosh it around, blow it through our booms, clean our screens, move on, and we still have an issue. The one thing that is rarely talked about, I was reading through some publications about tank cleaning, and I'm pretty adamant on this myself, is time. When we put that cleaner in the tank, we got to let it sit. And I had trouble myself last year on the research farm when we were trying to turn products over too fast. We're using tank cleaners, we're using ammonia, we're using water. We did everything by the book, and we kept on having issues. But the one thing we weren't doing is, you know, we were doing this in 15 minutes, flushing it through, instead of leaving it overnight to sit and pull everything out that could be bound to your lines and tanks. Question, Ken?
You're not the only one.
Yeah.
How long do you have to let it sit, you think?
So the recommendation I've been reading about is 8 hours, but I think the best way is do it overnight. You know, we don't always work all night. So at the end of the day, we're done spraying. You know, before we shut things down, you know, do our first clean and let it sit overnight in your tank. Come back in the morning, we go to step 3, and we march on. Now, I understand we don't always have 8 hours to spare. Sometimes we got to clean and we got to go that same afternoon, but it really depends on the product too.
I was going to ask which product.
So when we're going from pre-seed to into our canola, let it sit. We probably have time. There is a gap between our pre-seed and our canola, right? So we got time to clean.
But I meant what cleaners? Like, are you trying to finish detergents or all of it?
Tell you the truth, I would say all of them, but detergents for sure. You know, it's kind of like when you do your dishes. You know, I get in trouble if it's at home. I take my dirty plate, I throw it in the dishwasher, you turn it on, and it comes out still caked in food. You know, it takes time for these to come off. Sometimes you got to let them soak first, or do your first rinse before you put them into your detergent. So it takes time, and this is, you know, none of us have time. We're always in a hurry to get the next tank load. But I've proved this myself just this past year. We started doing that overnight sit, and I can't find one symptom on any plant. So time is critical, and very few publications talk about it. A few do, but for me, personal recommendation, if you can let it sit for 8 hours in a tank or overnight or 2 days, so much better, especially with the tank cleaners.
Can I ask you another question before you go on?
Sure,
This is actually an online question. First online question.
perfect.
From John Gibson. Have you compared volume of material left in various sprayers? That is compared what is left in the sump of a John Deere versus a case.
Yeah, so the question was, have we compared different sprayers to, you know, to understand how much is left in there? I have not. You know, I'm not an expert on equipment manufacturers, but again, all equipment's different. So if you have a sprayer, really understand where those pinch points are, you know, where the product is sitting, where your filters are, because they're probably all a little bit different, for sure. So that's a good question. All right, so we're on cleaners here, and I brought some examples. I got 3 different ones which are fairly common. Again, these are branded, but I don't want to talk about brands. This is probably the classic one. This was you know, branded as Finis, but it's ammonia. And I'm sure we've all used ammonia water. You can buy it in Safeway, you can buy it from your retailer. This has been a classic tank cleaner. Although I have a few concerns about calling that tank cleaner. This ammonia has a different purpose than a cleaner. This is more of a solubilizer and a deactivator. And the reason we have it is very common with the group 2s, as I showed you over here, the sphanureas. They become more soluble at high pH. And some of the reason is they tend to tie up, is our spray solution is probably neutral to slightly acidic, you know, 6 to 7 pH, depending what we've added to it. They're not very soluble. So when we rinse with our water, we're not pulling them out. We have to get product into solution to flush it out of our sprayer. When we add ammonia, very high pH, we get that pH up to that certain level, then it becomes soluble, and then when we do our rinse, we can flush everything out. As far as a tank cleaner in terms of removing oils and you know, some of that buildup, not as effective. There's lots of recommendations about add your ammonia as your solubilizer, deactivator, but then add some adjuvant as a cleaner. Lots of different recommendations, but we need to get some detergent with this, especially if we have any buildup on the tank. So this has a very special purpose. It works very well as a solubilizer, possibly a deactivator, not always, you know, a good stripper for removing some of the sediments. This is not quite as common, but bleach, I've heard, kind of does, you know, we can buy it in Safeway. I think Walmart, $2, very cheap. Already has the same effect as the ammonia. It raises the pH. I'd say probably not as effective in raising the pH. And you got to be very careful, because if you mix bleach with ammonia, you form chlorine gas, which is toxic. So there are some concerns about safety when we're working on some of these products. These are becoming more common now. Tank cleaner. I like these. I'm not recommending a specific brand, but this is what we use on the research farm. It's got a detergent built in for removing those oils, but it also raises the pH. So it's doing what the ammonia did, but it's got the strippers in there as well. And I've had good success with these if you leave them for several hours, you know, in your booms, in your tank, to give it time to work. You know, they come with a label. So I know sometimes when you buy ammonia from Safeway, the instructions on how to clean a spray tank are pretty limited. I don't know how much to add. I don't know what to be putting in with it. I don't know the safety precautions. At least these come with the label, use directions, you know, so on and so on. You can buy them in already any of your retailers who, you know, would probably carry them. And they do cost a few bucks. I don't know what this costs. I bought it last year, didn't pay attention, but probably a lot cheaper to buy a jug or 2 of this than having to reseed some canola or lose several acres. So relatively compared to what we're going to spend on our chemical program, you won't even notice a few dollars of tank cleaner. So I like these. There's more and more on the market. I know I don't have a brand I love. I just kind of give me whatever. I read the labels, but I do like the detergents in there and raising the pH at the same time. So doing two things in one. So that's step 2 is the cleaning. 3 is our final rinse. So we want to flush all of that cleaner out. You know, we should be spraying it out on a waste area or on part of a field. Or I think Ken, Farmer Smarter, has bio beds, which is kind of a new thing. Is that what they're called? Yep. Bio beds for disposing. It's a great idea, but we want to get rid of that. And our final step, in that step, we're cleaning all of our screens and nozzles. That's another place we see missed. You know, when people have new sprayers, there's a lot of filters in there. So sometimes you miss one filter, pretty devastating effect if it's a main filter going into your tank. So you got to know where your filters are. Got to clean each screen. Good idea, you know, as you're letting your tank sit, take all those screens, throw them in a pail cleaner, let them sit overnight. It's the same thing. It takes time. If you have sediments built up on them, you know, toothbrush works really good. Get everything off your screens. Then our final one is really our rinse, which is back to our dilution. If there's anything left in there, we want to strip it out. So we do a final rinse, and we're ready to go with our next tank load. So, you know, it's not a 20-minute process. We have a little 3-point hit spray in the research farm. It probably takes us 3 hours to go through all the steps, plus letting it sit overnight. I have not cleaned a big sprayer myself, but I'm sure it's several hours to get through it. But critical when we're going into sensitive crops that we take the time to do it. Any questions there? I'm going to stop for a minute.
As far as screens, like most times when I take screens out, stainless steel screens, they look pretty clean. There'll be a couple chunks of whatever.
Yep.
Usually it's not chemicals, things it's caught. But other than rinsing them, they look clean. Like if it's stainless steel, can it hold much if you rinse it off?
Yeah, so the question was about screens. He had the comment, he pulls them out, they look clean. You know, are they really clean? And I say that they probably are. Typically on a screen, you know, we use 50 mesh. You know, that's the size of the orifice to go through. You'll see the particles sitting on there. You know, I don't think the particles are small enough that they really bind to that mesh and you can't see them. It's that visual one. And if you're using dry products, it's worse because not all dry products dissolve 100%, and you start to get that buildup. But if they look visually clean and you threw them in some tank cleaner, they're going to be fine. You know, I'm not worried about that. You know, it's when you pull them out and they're white.
Yeah.
That's the issue, because that's probably active ingredient plus some clay carriers, and as you spray, you know, those particles will come off and could cause an effect. So visually, inspection, you know, throw them in a tank cleaner overnight is good for a screen.
Do you have a list of chemicals that you see more problems with, like certain, or maybe it's just groups?
Yeah, so the question was, do I have a list of chemicals that cause more issues? And I'd say I do not, but groups for sure. You know, the reason I showed sulfonyl ureas group 2s, because we've been using them for a lot of years, very effective, commonly used. And in the past, you know, they have caused issues. Number one, you know, look at the label. If there is an issue with a product, it's probably going to be on the label about the recommended cleaning procedure, you know, whether to use a tank cleaner or whether to use an ammonia water. I will admit, and I've written some of these labels, quite a few, the labels are not perfect in describing tank cleanup procedures. Probably an area of improvement that we can work on, but at least they'll tell you, you know, if it says use ammonia, it's probably for a reason, because we want to solubilize and deactivate. If it says, you know, use a commercial tank cleaner, it's because it'll form an oil and we want to pull that out. So read your label just to get an idea. But there are differences. You know, we're very good at cleaning out glyphosate. Typically some water, dilute it, works. It's when we're adding other products to it, you know, surfactants and other products. Sulfonyl ureas have been classic. That's probably where it started years ago with some of our cleanup procedures. Again, it's that solubility issue. They're not that soluble at the pH of our water that we're spraying, so we got to be a little more diligent about that. So yeah, you kind of got to get to know your chemicals a little bit too, and I would always start with the label, you know, as a starting point, just to get an idea of what the precautions are. What's that?
Clean once in a while, the wool sprayer, the booms, everything.
Gr-
There is some stuff sticks on it. Just micros
Yeah.
can kill something.
Yeah, that was a great comment. You know, I talked about cleaning the inside of your sprayer. What about the outside? Yeah, it's probably a great procedure to take the high pressure washer to it and clean the sediments off. Something like dicamba on non-dicamba tolerant soybeans. If you have dicamba on your pants and walk through a soybean field, you can get injury, like hypersensitive to things like that. But same thing, you got solution dripping off your sprayer. It could pick up an old residue and drop on a plant, cause injury. So cleaning the outside, good for your plants, probably good for safety too. You know, we're touching all those parts, so it'd be great to clean the outside and keep that cleaner. So thanks for your comment.
Another thing we've got an issue with the ends of our booms, so we got to take the caps off and put valves on so we can blow the ends.
Yeah, the comment here, great comment. This is a classic problem we see is about the boom ends. And in some of the spares that come, I'm not sure why they build them this way anymore, but you have a nozzle and then you have a 6 or 12 inch gap where the tubing's plugged off. What happens is particles get caught in there, but when you rinse, you can't flush that back. And so you get this problem with your last nozzle, you get that streaking in the field. And so more and more common is to put valves on the end, or some of the new spares actually have continuous flow, so it flows back through, back into your tank. And that way when you clean, you can either blow it out the ends or blow it back in your tank and rinse. But that's a great recommendation, is if you have that gap between your last nozzle and there, is to put a valve on there so you can blow things out. So thank you for that comment.
I was going to ask you about the continuous flow booms. We've got a sprayer with that now too. And I see that there are claims that can speed up your cleaning time, but I have a hard time understanding why that would be. What are your thoughts on that?
Yeah, not an expert on that at all, but I'm going to go back to my comment about time. I think my opinion is why we don't see that in publications is because that scares people off. If all of a sudden I got to say leave it for 8 hours, like, really? Like, you really want me to do that? Well, it works. We're busy, so I think maybe it does. I haven't researched it, but I wouldn't rely just on that. I would still let products sit in my tank for a while. It helps with the accumulation on the ends that you can't clean out because it can blow everything back. So maybe it does speed it up, but I don't know how much faster you can do it on a continuous boom versus a non. Yeah, so the question was about the chemical injection sprayers. So instead of having a spray tank, you'd have a canister, and each canister would hold different chemical, and it would inject it on the fly. I don't have a lot of experience. It would solve the tank clean out every time. However, when you change products, in that canister or tank from one product to another, you're still going to have to do a thorough clean. It's just they're going to be a lot smaller. Your water tank's going to be your 1,600 gallon tank, and you're going to have, I don't know, 5 or 10 or 15 gallons small tanks. So I would assume it'd be much easier to clean out, but there's probably still room for error, as you have to clean that chemical tank out very thorough. So. Not a lot of experience. I've seen a little bit about them, but that would be my comment. Yeah. All right, Ken, how are we? Oh, one more question here.
Do you know of any funding that's available besides the CAP program? That's for contamination beds and also for sprayers.
So the question was, do I know about any funding for some of these bio beds or some of these programs for cleaning out sprayers? Actually, Ken would probably know more. He's got a program on this, on bio beds. So.
There's a spot that you have to apply specifically on the biobed one. I'm not sure about
And sprayers as well.
the sprayers part, but
There's, under the CAP program, farm stewardship.
yeah. What was the program title?
Under the farm stewardship.
Yeah, so there is a code for it, and if anybody wanted it, you could talk to the lady over here and she can give you that code, but she has the information for some of it. So we're wrapping up here, but certainly ask and we can provide that to you. So I think we're probably close on time, Ken, or?
Doing all right, but if you want to end it now, that's cool too.
So you know what, why don't you have a look at some of the symptomology? I can walk around, ask me questions one-on-one, like spend a few minutes here, and then whenever it's time to move on, let's just give us the word, Ken.
Sounds good.
But I'll be happy to answer questions. If it's a great question, I'll repeat it to the group, and we can all hear it. So. Yeah, the front and back are the same. It's ready 2 reps. Again, the symptomology about the spray patterns didn't really work out the way it should, but we can see, the symptomology on the individual plants from the different chemical groups.